Right, so let's take a look at this first one. This is where you're searching for the letter A and replacing with X. Nice, simple example. Just, oh, yeah, all right, sorry. There we go. Okay. So the first thing I would note that is good is that I don't have to pick up my pencil at all. So this is always the very first test to see if you're doing these things right. So that's my and oh darn it, doesn't want to cooperate. And so I can go through this whole diagram without, I don't have to finish it, without picking up my pen. So that's definitely the first test that you're using the tool correctly. So from buffered file, you say get, and then this right here is showing a relationship that we didn't necessarily have before, which is good. You're revealing a relationship between buffered file and the deck. So presumably this is like a private data member or something like that of your buffered file. Now, so presumably there's some stuff happening right here. Is that right? This is, what is this actually interrogating from the file or somewhere else? Right, so at what point are you actually doing the low-level get from the actual F stream?
When the main function calls the get on the buffered file, immediately does the low-level get on that.
All right. So, yeah, so I think definitely you have a push front here, which assumes that you have a character in hand to push onto the deck, right? So presumably somewhere around this point is where you're actually interrogating the file. So it would be good in the diagram to maybe have something represent the actual F stream. So just as there's a relationship between buffered file and my deck, which is a private data, this is an inheritance relationship, but there's no reason why we can't actually split it out in a sequence diagram. So you call get on buffered file, and then it calls get on the F stream, returns a character, and then that character you're pushing on, and then that gets returned back. Now, so, this isn't necessary. I'm just saying that it's an idea, and if it's helpful, you can certainly break out that inheritance relationship. The next thing I note is that you are grabbing the character from the deck and returning it, and then here you're doing the match right here. And depending on whether if the character was A, then you replace character BX. Otherwise, you would push back. You would put whatever was returned here. Is that right? Yeah. So the next thing I note about the diagram then is that main has a relationship with my deck, which then makes my assumption a bad one, that my deck is private data of buffered file. or I should say they're in conflict. If I just look at the top half of the diagram, it seems like a good idea that buffered file, or excuse me, that my deck is private data buffered file, but that definitely flies out the window once you're accessing it directly here.
Yeah, I think the callback should have been from buffer file.
Okay. Yeah, I'd buy that. So rather than these lines going all the way to main, then our starting point is right here, and it's coming right here. So that would imply that there's some sort of message right here then, right? So
Actually, then you return all the way, you return to the file, but then all the way back to main to do the comparison.
so would the comparison occur right here?
No, I mean, you have the extra arrow.
Right here?
Maybe another one underneath to go back to main.
Yes. Nope, don't do that. Apple's preview tool isn't the best drawing tool. Yes, so the arrow is, there we go, going that way. What would the name of this be? So you get the character, and then you, so get interacts with the deck, but doesn't give anything. It just gives buffer. What interacts with the deck?
The file,
The F stream or the buffered file?
the F string.
All right. So the problem with saying that the F stream interacts with the deck is that the F stream is code that you can't modify, and there's nothing in F stream that interacts with the deck.
But it interacts via the file.
All right. So let's take it from the top. Well, let's actually pull back a little bit. Let me. Let's look at the start. I wish I could. Maybe I can. Give me in a sentence what you want to have happen with this part of the sequence between here and here, the call to the return. What should get do? It should get a character from the file and put it on the deck. All right. And then in a sentence, then what would this one do? Starting here and ending here. Ah, okay, so that's important information. So what you're proposing maybe is that this match is what, like occurring over here somewhere? Yeah, you do have it in main. So let me go back to what you said. When I said, what's the purpose of this, where you're kicking off here and it comes back, you said, I think, get it from the deck, and I don't remember your exact words. It was something like, get it from the deck and do a comparison, right? So that's kind of what I hung my hat on when you said that, because by if it's between here and here, it would have to be somewhere in this part of the sequence. So if this is to get it from the file and put it on the deck, then this one is to, yes. I mean, anyone can jump in, right? So what I'm doing is I'm just trying to continue the brainstorming just a little bit.
Seems to me that I don't know if this is just the first or second or third case, but first.
Yeah, and it's the one character, replace A with X.
I
that we only need to put the character onto the deck when the replaced string is greater than the set string. If we do it all the time with this code, then
All right, so for the sake of the recording, you're saying that we should only interact with the deck in the case where the replaced string is larger than the search string.
yeah.
Okay.
And because of this, buffered file is used all the time, but the deck is
You can sit here if you want, and you don't. I appreciate you.
buffered file is used all the time for interacting with the F string, but my deck is used only in the third case when the replaced string is greater than the search string.
And what do you propose the relationship is between my deck and the rest of the application?
I propose that my deck should be in a relationship with main or some other calling function, because having it interacting with my deck with buffered file all the time, it just seems like redundancy that we could get rid of.
So let's jump down, look a little bit lower here. So when I lumped both cases in here, I wasn't really eyeballing that there. So you've divided out. I see how this tool's doing it. There's my positive if, and there's my negative match. And then you go back and start again. Okay. So the only questions then are regarding this thing interacting with deck. Along with that, we kind of agreed it might all push over here. And the second is whether the deck is necessary at all. Note that if I do a get here, another possibility is I get a character back here, in which case I can immediately jump down to this if statement. So let's keep that in mind, and let's see what we have going in another possibility. All right, so we have the same two objects. They're just reversed in order. So here, is there a particular case that we're dealing with here?
Case 3, when it's longer.
The replace is longer.
When the replace is longer, for case 1 and 2, I felt that the deck was unnecessary, so
all right.
that's
Okay, so let's look at this. Ask the buffered reader for a character. And then, so what's not being shown here, and this is perfectly acceptable, is all of this stuff, which is interacting with the F stream, right? So presumably here we have interaction with the F stream to get the character, and the 1 comes back. Is that correct?
Yeah.
And then you, yeah, exactly. Everything we talked about. You do the seek, and then you do the seek to the getter, whatever we called it, and then you get the character, and then you reassign what the current location of the get pointer is. You retrieve a 1. What was our contents of the file here? Was it 1, 2, 3? 1, 2.
1, 2, 3, ABC.
1, 2, 3, ABC, and what was the replacement?
Third string was A, replacement was XYZ.
I'm sorry, it was 1, 2, 3, ABC?
ABC, third string is A, replacement is XYZ.
see, 1, 2. One, two.
Those comparisons.
So why is there an X here? Put X.
If A is equal to the search string at 0, which it is, after that, put the X.
But we haven't found 3 yet.
Oh, that was omitted because it's in a loop and the diagram wasn't tall enough.
So you just kind of cut to the chase. So to simplify things, you did something like that.
Yeah.
Just kind of do the
So
same step again.
the first in one where we have one off to the side noted, that's where we read and compare all the characters that are before the start of the.
All right. So this is
First, like, imply.
okay.
Yeah,
Okay,
imply.
I'll buy that. Get, the 1 comes back. Put. It's loops. Get, 2 comes back. Doesn't match. Put. Get the 3. Put the 3. You get, the A comes back. What are these numbers representing? Are those like states?
One, those are like one. We get and put all the characters until
Oh,
the
you
start.
just annotated. Okay, I got it. You get the A comes back. If A equals search 0, which it does.
We replace it with the X.
You put X, right?
And then at 3 we store the overlapping characters into the depth. At 3, so we
You get
next character
B.
the B.
Then
Then
you push that. You push the B onto the deck. You get the next one. Push the C on.
and then
And then you put Y and you put Z. And then you pop back.
from the deck and put it.
Right.
And then we have the C, but again that's implied. So we have an arbitrary number.
Why was this B popped off right here?
Pop
Why'd you take the B off?
pop back because we've put at 4. It's implied that we've put the rest of the search string. We've put the rest of the search string, or the replace string rather. We put the rest of the replace string, which was Y, Z. If we would have more characters, we would have more characters being put, and then we start to pop back characters and put them.
So you went read write 1, 2, 3. You read in the A, and you write X, Y, Z, and then you're left with BC, and then you're putting those out afterward, right?
Yes.
All right. So let me give you an idea of why this project's such a bitch. Pardon that's my throat.
I understand.
1, 2, 3, X, Y, Z, X, Y, Z, C. So you've gotten the B and the C, or excuse me, this would be A. So now your pop back here returns an A. So what should you be doing at this point?
Once again comparing it to
You're doing a search then. This time your search isn't, your characters aren't coming from the file at this time, they're coming from the deck. Also, right, so in this scenario that's being documented here, this is an A, and it is getting pushed onto the deck. So I get an A and a C on the deck, right? So this becomes 1, 2, 3, X, Y, Z, and AC is on the deck. Now, according to this, it's just blindly popping off the deck and putting it into the file. Well, if you blindly pop this off and put it into the file, it's going to look like that. So the characters that end up on your deck need to be examined just as the characters you're getting from the file need to be examined. That's an excellent question. Are they examined when at what point are they examined?
If we examine before putting them onto the deck, we can possibly not put that character onto the deck, but we'll be minimizing our use of memory. We just do the replacement, and then if that character is not in the deck, we would need to do another. Record somehow that we need to do another replacement, so we increment the number of replacements counter, and then.
Why are we incrementing the number of replacements?
If we would have, as in our example, AAC, we would look at, okay, we need to replace it with A, so XYZ. And we look, XYZ is 3 characters long, A is 1 character long. Look at the next 2 characters. Should we save them onto the deck or not? We see A, another A. Okay, so we can technically not push that onto the deck, so then we need to increment the number of replacements counter. So 2 times 3, that would be 6. So we would subtract and then look into the difference. If we would have like
all right.
AC,
So let me pull back and let me propose something a little different. I like the simplicity of this. If we kind of avert our eyes at the middle bit, get a character, do the comparison, and then do the replace if necessary. Now, and I'll grant you this is the simple case, whereas this one's tackling something a little more complex. Okay, but this idea is attractive from an encapsulation, right? Get a character and you get it back. What I think that this relationship is good. I should have looked at. I haven't looked at my solution in a year. I need to look at my solution. I think that having the deck as private data of this buffered file is the way you want to go. And what you want is you want to ask for a character and get it back. And the point of the encapsulation and the abstraction is you don't care where or how that character was gotten. You just want to guarantee that you get a character back to do this with. Right? All right. So there should be a little more intelligence in this get function, which is there something in the deck? If so, grab it off the deck and return that character. If there's nothing on the deck, grab it out of the file and return that character. Now, this part of the algorithm that's currently in main then can focus on simply getting characters and doing comparisons and deciding whether to do a replace, rather than having to know what the state of the file is and whether you've got anything buffered up in that deck. So the next question is, well, so this changes this semantically a little bit. Here, as written, the assumption is that you always get it from the file and you push something onto the deck. Instead, look at it from a perspective of it's retrieving a character for the user, and you just have to decide where you're getting the character from. All right. So the next question is, how do we determine whether or not we want to put something on the deck? No, if we want to put something on the deck. not if it's empty or not. If it's empty, whether you want to retrieve something, whether you want to pop something off the deck is dependent on whether there's anything in the deck. I'm asking a different question. Under what conditions do you want to push something on the deck? And so keep in mind with this,
That's what I meant, right? You said if the deck is empty, do we maybe get the captain to file it instead? Right?
yes. No, right.
So if the deck is empty, get the captain to file, but put it onto the deck.
Right. Okay. So there's where I want to part ways and suggest a different, slightly different use of the deck. That's fine. You can keep that.
What if we take the size of the replacement string and the search string? We subtract the size of the search string minus the replacement string, and if it's greater than 0, then we have some characters that would be overwritten by the XYZ. So we need to save
Right.
them.
And I understand that, and you can create an algorithm that's using the mathematics of the difference in the size of the search and replace. But let me propose an even simpler mechanism. So here's my file. I'll just use, again, I won't use arrows, I'll just use G and P. If I had my tablet and so forth, I'd probably draw a picture. So I can do get. I can do puts. At what point do I screw up my algorithm? Just from the perspective of, right, I'm looking at the idea of these 2 pointers, or we are semantically creating those 2 pointers. At which point do I screw up my integrity of my file? Now, all I'm doing is I'm moving these stupid letters around. Imagine these are actually gets from the file, and these are puts to the file, but I'm not showing what's being put. It could be FDSA, it could be XYZ, doesn't matter, right? So I'm throwing aside what exactly we're searching and replacing, but at what point does the integrity of my file break down? When what relationship, position-wise, do these pointers have that destroys the integrity of the file?
Well, if the put pointer advances past the get pointer, you put stuff.
That's exactly right. You're putting stuff that hasn't been read yet. You're overriding stuff that has not been read yet, right? And you've lost it for all eternity. Does this make sense? No, because it can't go in the deck unless it's been read from the file.
Your deck is one step behind. It's not possibly put on the deck.
If it's
So imagine that put just puts the letter X all the time. Get, put, get the D. Well, let's see. No, I don't want to put X all the time. Let's say it's just a stupid algorithm that reads in the letter and writes it out. As long as the put pointer, get the G, get the F, put the F, get the D, put the D. As long as this put pointer stays even or behind the get pointer, then that's fine. But the moment I put something out before I've read it in, I never have a chance to get that S. All right. So my proposal for your use of that deck is whenever you want to put a character, compare the numeric value of these 2 pointers, and if, again, we're talking about put, if P is equal to G, then do a get, put it in the deck, then do the put. Yeah, even or 1 ahead, right. So looking at the level of this diagram, I've got get and I've got put. It's actually put that controls the population of the deck, because it does a little internal check to see if that getter is even, and if it's even, it needs to do an internal get, put it on the deck. and then it does the put. Does this make sense? And when I say do an internal get, I'm very consciously using the word internal, because when I say do an internal get, I'm specifically trying to avoid this. When I say internal get, I'm not saying do this. This is something different, right? There's some buffered file has some sort of internal relationship with the F stream.
Would storing the character as a private member of the buffered file, the character previously gotten as a private member of buffered file, give us anything?
Of the what? The most recent character gotten?
Yeah, if we do a get, we return that character and we save it into a private variable of the buffered file. So that
the answer is I don't know. If your algorithm needs it, then you do it.
We split this up into these three explicit cases with comparing the lengths of the search and request strings, or is there a good way to kind of map them into one?
Right. So I kind of coach this differently every time. So let me say that definitely I've gotten a lot of solutions that break them up into the three different kinds. I think you can avoid that altogether if you follow what we just now talked about. You've now, the only reason for the deck is that third case, right? And you will find that if you do the little internal get here to fill that deck, the only time that'll ever occur is in the third case. And what it does is it makes this part of the algorithm totally oblivious to the relative size of the search and replace strings. It'll just get characters whenever it needs to get characters, and it'll put characters whenever it needs to put characters, and something at a totally different level of abstraction will handle the problem if the replace is bigger, because if the replace is bigger, the put's going to want to go past the get, which is going to force your internal get to fill that deck. So that's part of the beauty of encapsulation, is this part of the algorithm doesn't need to be cognizant of that.
Can you see your sequence diagram?
I think I only have a sequence diagram for my object-oriented solution.
so that's for the next state.
Right, so I'm hemming and hawing a little bit because, as I said, I kind of coach this differently every year, and I don't remember what I have done in previous years. So it may be that you all may not have nearly the problems as some of the previous classes have had, because I've helped you particularly with the strategy of only putting something on the deck when your put is going to collide.
How does the idea of the state machine
The state machine can sit out here at this level of abstraction, and your states are searching, a potential search, a matched search, a failed search. I think that's about it. I'm searching for, when my search is A, B, C, D, and my file yeah, I'm sorry. Yes, thank you. You corrected my language. Yes, that's what I meant to say. Potential match. Thank you. When you're in the midst, when you find the letter A and then you find the letter B, right? You have the potential of the match, but you aren't there yet, because it can go one of two ways. Either you've got A, B, C, D, and now you're going to do a replace, or you've got A, B, C, X, and now you've got a failed match. So I don't know if I made that a state, but that would be a state, failed match. So, if we're being all official and so forth, we would go back to the drawing board and do the diagrams. I'm very sympathetic that in principle, you all see the value to the diagrams, but I think there's a level of diminishing returns in me forcing you back at them. I think I'm far better served by having you do this first pass with it. And now I'm happy with you going and trying a little bit of code. So I'd like you over the weekend, try writing a little bit of code based on what we talked about, kind of encapsulating that get and that put to use that deck only when the put pointer is going to overtake it, and write that chunk of code on the back end, and then try writing some of this algorithm here. You should always be using the tracking deck, absolutely. And so what I would like to start being in is in Q&A mode on Monday, because hopefully you all will start to run into problems, and then we can talk about some additional strategies for getting through this.
So the tracking deck and my deck are the exact same thing.
Yes. Yes, tracking deck and my deck are the same thing. I should have called it tracking deck all along. I just wasn't on my game. All right, everyone good with that? Okay, if you could bust out a little code and run into some problems, that makes Monday so much more useful to you. Huh? What if you say it again? If you solve it without problems, then you're in wonderful shape and you can kick back and relax for a while.